Yep. Okay, so to get a quick intro. So good evening and welcome to the 2022 Lockheed Martin lecture, which is on LM Sport UK Space launch. And I think by my count, it's been about 10 years of hosting these lectures. Lockheed's been supporting these lectures, so that's pretty good going and much appreciated. Our speaker today is Grant Lewis, project manager, who is working on the UK satellite and launch program, aiming to deliver pathfinder launch for UK space from a UK spaceport in the early 2020s. So I'm going to hand it over to Grant now.
Okay, thank you very much, Dan, and thank you for coming along this evening. Delighted to be here to talk a little bit about what we're doing and some of the activities that we're really excited to be a part of, and what we're going to be looking to deliver on UK shores over the coming months and years. Just before we jump in, a little bit about my background. So I'm a project manager by trade. So I've been involved in a lot of project planning, project management roles. I've worked for Lockheed Martin for around about 17 years now. I did have hair when I started, but I've quickly grown through that, all the variety of both defence and commercial programs I've worked upon. But now working on, as Dan said, our UK satellite launch program, and some really exciting work that's being done, and especially on and in the UK. So what I'm going to kick us off with is a little bit about Lockheed Martin Space, just to try and frame a little bit about the organisation. So Lockheed Martin Space is one of a number of business areas as a part of corporate Lockheed Martin. In the last year, we returned around just under $12 billion worth of sales. And as you can see, there's the space line of business is a significant portion of our overall corporate portfolio. We have a number of customers, as you can see listed there, predominantly focused on kind of defence and commercial aspects. And our programs are predominantly spread across 6 major areas. So we have a strategic and missile defence area of the business. We then look at both civil and military space. We have a mission solutions division. We have a special programs area. That's all the secret squirrel stuff that we're not allowed to talk about. And then we have a number of joint ventures that we are actively a part of, and you can see some of those listed at the bottom there. So in terms of space, we're one of the biggest, if not the kind of biggest space company in the world. If we focus in on that Lockheed Martin space business area, we've got just over 21,000 employees. They're split across 7 countries, nearly 200 facilities. And over half of those employees are scientists and engineers actively helping us deliver all of the really exciting and innovative work that we do. To try and give this a little bit of a UK flavour as well, Lockheed Martin UK is an entity, and we've been operating out of the UK for just over 80 years now. We have a footprint of about 1,800 people, and they are based around about kind of 20 sites covering the length and breadth of the UK. So what do we bring to the party, and what does Lockheed Martin add to the space activity within the UK and the projects that we're working to a part of? So really what we're bringing kind of performance, we're bringing innovation, we're trying to bring some of the legacy and the successes that we've had on other programs and missions, and help bring them to the UK, and help stimulate the UK kind of space sector if we focus on launch. So as you can see on the screen, we've built in the region of 1,000 satellites under our strategic missile defence business. We've had 178 successful Trident II D5 missile tests. We've been involved and supported every NASA mission to Mars. and developed hundreds of payloads over the last 50 years. So we have got a very kind of rich heritage with all things space that we're extremely proud of. And what we really want to do is take some of that knowledge, experience, capability, bring that into the UK and help kickstart the launch sector, I guess, within the UK and support the UK government's ambitions of growing that indigenous capability. So that kind of frames a little bit about Lockheed Martin Space and who we are and what we bring to the table. So I thought then what I'd talk about a little bit is what is the importance of space to the UK, why are we undertaking some of these space activities in the UK, and then we'll touch upon a little bit about our program specifically. So if we look at space in the UK, what we're trying to do on our program and across many other programs is help to try and establish commercial vertical and horizontal launch from UK spaceports. You can see on the map in the bottom right there, there's the UK Space Agency has invested and is supporting and as part of various studies has identified a number of potential spaceports. The three there in the north of Scotland are all vertical spaceports, so they're your traditional rockets standing on end, launching from the Earth up into orbit. And then in the south west of Scotland and then into the south west of England and Wales, we've got a number of potential horizontal launches. So that's what you may have seen the likes of a Virgin Orbit perform recently in the news or online, where a rocket would be attached to, say, a 747. That aircraft would be taken up to a certain altitude, and then they would deploy the rocket from the air rather than the ground, like we are trying to do with our kind of traditional vertical launch. And really, the government's vision, they have what's called their spaceflight program Launch UK, and that's trying to help kickstart this part of the sector, trying to ultimately deliver a launch capability within the UK, and then it's believed that the UK will then have a full end-to-end offering for industry, because we already have a pretty rich heritage in research and development. Glasgow itself is one of the biggest manufacturers of small satellites in the world. We have experience with data services and analytics. So we have quite a breadth of expertise across the launch sector. The part that was really missing to be able to offer that full end-to-end service is launch. Traditionally, anything satellite-wise that would be built in the UK would have to be shipped off around the world to piggyback on launches from other global spaceports, where the intent now is things can be built in the UK and shipped to UK spaceports. So if we look at, well, why the UK, I guess there's a number of kind of key areas, and I've tried to summarize them here. So the first part is geography. So we can get into and access a range of different orbits. So certainly a lot of our missions are going to be looking at polar and sun-synchronous orbits. So that's where you'll put satellites into a low Earth orbit and be able to effectively scan the Earth, look at weather monitoring, look at imagery, look at those aspects. A lot of it can help towards climate change by monitoring the Earth and monitoring changes and helping inform us of things that we need to do. So the geography of where we are in the Earth helps. The other part of the geography is you'll notice from that previous map that a lot of the vertical launch sites are all on the very north coast or the islands of Scotland, and that's pretty much because of the vast emptiness above there up to the Arctic Circle. So as you can imagine, from a launch perspective, we want to make sure things are inherently safe. We don't want to put public safety at risk. So where we can launch where there's not inhabited areas maximizes that potential and minimizes the chance of any public safety incidents. So that's a couple of kind of key takeaways or highlights from a geography perspective of why the UK makes sense to try and develop a launch capability. The second point is the environment. I think the UK space sector, from last reports, is worth nearly £15 billion and employs tens of thousands of people across the whole of the UK. So there's already a bustling, thriving UK space sector out there. The economy is growing as a result. So what we want to do is piggyback onto that. And as we discussed on the previous slide, if we're trying to build an end-to-end service, we want to supplement and we want to complement the existing services and activities that are already out there. The third part is we can leverage industry. The UK already has, as I mentioned, a lot of space expertise. We have world-class aerospace expertise, knowledge, experience, and capability that we can leverage. And obviously there is a lot of synergy between aerospace and space activities. So we've got that good foundation and that good industrial base to build upon. The other part that we need from a UK perspective, when I say we, is a regulatory environment that enables us to be inherently safe and have everything approved, but something that's dynamic and kind of pragmatic, because what we don't want as the UK is we don't want regulations that will stifle the growth within the UK. We need them to be, I guess, supportive of the activities that we're trying to do and enable launches to take place safely as quickly as we're able to do. And the UK government has helped move that forward. They put in place the Space Industry Act in 2018, and then that was followed up with the space industry regulations last year, along with the Civil Aviation Authority being announced as the spaceflight regulator. So they will be the team charged to license all of the spaceflight activity. And I'll touch a little bit more on regulations later on, but the intent is having a strong and dynamic regulatory regime from which to license all those activities. And from the early indications, the suggestions are the UK government has looked at what goes on elsewhere, and it is trying to tailor something that will enable them to be at the kind of cutting edge from a regulatory perspective. And then lastly, relationships. We, as an island, we do already have strong global links all around the world. So we're able to leverage those networks and those links to bring business in, and to connect all the dots as we try to build that true end-to-end sector. So what I'm going to touch upon now is a little bit about our program and what we are trying to achieve on our UK satellite and launch program. I do have a short video that's about to come up, so that will give you a little bit of a break from my voice, and let me catch up with some water. But really what we are trying to do is show and deliver a vertical orbital launch. And we're trying to target that currently within 2022. So the genesis of our program was the award of 2 grants from the UK Space Agency back in July of 2018. And what those grants were the 2 projects highlighted on your screen. One was focused about developing launch capability. We'll touch upon that more on the coming slides. And the other part was more about the payload, about the upper stage, and developing what's known as a small launch orbital maneuvering vehicle, and then the development of some CubeSats to fly upon that OMV. So that's what we've received grant funding for, and that's what we're working to deliver. Clearly, we can coordinate that, but we can't get very far without a spaceport. So we're working very closely with the Saxavord Spaceport team, who are working on the design build and of their spaceport and making that fully operational to support not just our Pathfinder mission, but also for a variety of other potential customers. So what I'm going to do is I'm going to play a short video now. It's only about 90 seconds. There is no sound, just in case you're wondering. I just thought we'll keep the sound off and hopefully it will run a little smoother. Okay, hopefully that played okay for everybody. And that gives you a little bit of a flavour of what we're trying to do. So what you could see there is you could see the launch vehicle at an artist's impression of the spaceport in Shetland. That was going into low Earth orbit, where we're then looking to deploy our orbital manoeuvring vehicle that can house up to 6 small satellites or CubeSats, which we can then deploy into various orbits. And that's fundamentally what we're trying to achieve in our UK satellite and launch programme. But as I mentioned, the grant funding that we received had 2 projects within that programme, one focused on launch aspects and the other focused on the upper stage or the payload. So I thought I'd talk a little bit more about what we're trying to do under both of those. And then I'd be more than happy to take any questions that you may have. So if we talk about our launch project, what are we trying to do? So we have secured a company called ABL Space Systems. They're based in El Segundo in California. We have signed a launch service agreement with them. And with that agreement, they are providing a launch vehicle. They are providing what's called their RS-1 launch vehicle. They're providing all of their supporting equipment, their ground equipment, and personnel to support all the launch activities and operations. And the intent is that will the ABL team will be building, packaging up, transporting all of that equipment from California to Shetland, to the island of Unst, and then we will be supporting them in conducting the launch operations and getting a successful launch away. As it stands, ABL have not yet done a full first flight of their RS-1 vehicle. They're currently going through that development process, and we're working closely with them. They've anticipated that their first launch will be within the next few months. The intent is that they will have a couple of launches at least under their belt, and these will be US-based launches from US launch sites before we conduct our UK Pathfinder launch, mainly because we want to use proven technology and de-risk as much as we can the launch from a UK perspective. So that's what our plan is. But the ABL team are going through their development and testing. They're gearing up for their first launch, and they're going through all the necessary licensing activity that they need to get all the regulatory approvals to do that. And that's all being done through the Federal Aviation Authority in the US. So sometimes the questions we get asked in our program is, why are we using a US launch vehicle? Why are we not using something British or other alternatives? Well, I guess there's a couple of items I've put here, but there's some other aspects that we can talk through. So first of all is choice. We want to maximize the scope of the Saxavord Spaceport by supporting a wide range of options across what we're deeming as the small launch vehicle class. I'll touch upon that more shortly, but really what we're trying to do is the Saxavord Spaceport is being designed and built to have, over time, multiple pads and therefore the ability to cater for a wide range of different customers and different launch vehicles and rockets of different shapes and sizes. So some of their customer base is suborbital, so they are going to be smaller, much smaller rockets. So we feel that the Saxavord Spaceport being able to offer kind of suborbital launch all the way through to orbital launch like we're doing on rockets that are in the region of 30 meters tall, then there's a good broad kind of portfolio of launch activity they can offer. The other thing that this particular project enables, and us using a US launch vehicle, is our ability to road test the technology safeguard agreement that the US and the UK governments put in place and signed last year. Really what that enables is US launchers and US launch technology to be brought into the UK to facilitate launch of US launcher technology from UK shores. A lot of it is to do with security and constraints and controls around who can see some of that technology. But what that does is, by the good work that the governments have done to put that in place to enable US launchers to launch from UK shores, we will be able to kind of test drive that process through our launch. But what will happen after that is there's therefore the potential for other US-based launchers to be able to come and launch from the UK, whether that's from the Saxe-Ford Spaceport or one of the other spaceports that we mentioned earlier on across the UK. So those are a couple of the reasons. I think in terms of why are we not going British, well, Lockheed Martin is our role in this is as a mission integrator. So we're working with various partners to pull together the program and help drive it forward. We don't manufacture our own launch vehicle for the purposes of this program. And then there's also already companies out there that are moving forward with their own plans. So we know, for example, Skyrora, they've currently got a deal with Saxe-Ford Spaceport for potential launch of their vehicle. We know Orbex, that are based up near Inverness, are developing their prime vehicle, and that's going to be used and launched out at the Sutherland website. So we feel that there's already some British or UK built rockets out there that are being used from various spaceports. So again, if we're looking to open up the market, we're looking to open up the sector and grow the UK space industry, then us using a US launcher can only help that and open that aperture for future successes. If we then look about, so some people will ask then, well, for using a US launcher, we're also relying on Lockheed Martin, who is a US corporation. Well, what does that mean for the UK? Well, there's lots of benefits. There's potential for the procurement of some of the ground support equipment or interfacing of hardware between the spaceports and the launch vehicles that are being used. So that's something that we can use UK suppliers for. We can use local Shetland suppliers for if we use the Saxe-Ford Spaceport as an example. There's naturally going to be a lot of supply chain opportunities coming out of the spaceport, because they're not just going to have to design and build, they're going to have to operate, they're going to have to run a range, they are going to have to think about commodity provision and having gaseous materials and fuels and oxidizers and a whole host of materials that are going to have to be shipped into the site and held on site and managed. What might also be possible is in the future, ABL may consider developing a UK footprint. I can't say that definitively, but that's obviously something that they could look at, as could any other launcher that comes into the UK. And then ultimately after that, what we're really looking for is, once we've done our pathfinder and proving that we have a launch capability, we want to then look towards an enduring launch cadence. So building up a regular cadence of flights out of this various spaceports over a period of time. And really what we're expecting is, in the early days, it's going to be onesies and twosies while we prove the capability and we learn and we get data, and that will build up over time, so we get to a steady launch cadence, at least out of the spaceport. And that cadence will be built up not just by Lockheed Martin or ABL, that will be any launch provider or customer that wishes to use the Saxe-Ford Spaceport, or indeed any other spaceport in the UK. So as I mentioned earlier, we are targeting launch in 2022, but we have a huge amount of dependencies on that, as you'd expect of a kind of large infrastructure project such as this. So we do have dependency on ABL being ready and getting through their launch vehicle development and licensing. We do have a dependency on the spaceport getting through final planning, design, build, and becoming fully operational. And then, as we touched upon, the regulatory licensing regime and making sure that everything that we do and all the applicable licenses are approved and in place before we conduct any operations. So the next part, I just want to touch upon, why did I reference small launch vehicles, and what do we mean by small launch vehicles? So you can see there from the graphic, it's just for context. It's definitely not to scale, but really, so what we have seen is some people talk about the UK spaceports being the next Cape Canaveral. That is not what we're trying to deliver across the UK. You can see there that really what we're looking to address from a rocket size is what's in that red box. There's a couple of examples there. There's an ABL RS1 and there's a Rocket Lab Electron. And really we're going for the smaller end of the market. That smaller end of the market comes with some benefits. It does enable us to provide more flexibilities to customers, because we can give them more dedicated missions. we can try to provide more economical access to this space. That's typically defined as price per kilograms. There is a balancing act here because some of the bigger rockets you can, for one of a better phrase, rack and stack and launch a lot more small satellites from that one larger rocket, such as a SpaceX Falcon 9. So they might be able to offer some economies of scale and drive down price. But what small launch vehicles can do is they can compete with that to some extent because the vehicles are smaller by nature and therefore are cheaper by nature to procure. But then that balancing act of being able to offer more of a dedicated mission and be able to get the customer's satellites closer to the exact orbits that they need to be, and not just be sitting on a ride share and being secondary to someone else's mission. As I touched upon earlier, if we think about rocket size, we're talking the RS1's probably towards the top end of the small launch vehicle of class, around about 29 meters. But really, typically, we're seeing rockets that are about 15 to 30 meters sitting that class, with a diameter of around about 2 meters. So, and I guess coming back to the whole Cape Canaveral reference, again, using small launchers means less infrastructure that we require, and therefore has less of an impact on kind of the environment. If we look at the spaceport at Shetland, which I'll touch upon shortly, you're looking at a few concrete pads and a few buildings. So the actual infrastructure that we need to put in place to satisfy small launch and to facilitate the launch of these small launchers is greatly reduced. So that's really what we're trying to focus upon and deliver within the UK. So now I'd like to touch upon a little bit about the spaceport itself. So as I mentioned, one of our partners, Saxavord Spaceport, are responsible for the design, build and operation of the spaceport. What they're trying to achieve is a commercial operation here and attract a variety of different customers. So for those that are not familiar, you can see the map of the UK in the bottom left there. So Shetland on the second picture in is made up of 3 islands: mainland, Yell, and the northernmost island is Unst, and we're looking at a launch site on a peninsula on the northeast of the Isle of Unst. What else you can see in here? Some planning pictures that are publicly available. I'd really bring your attention to the bottom right image. Appreciate it might be a little bit of an eye test here, but you don't need to read any of the text. But fundamentally, what we're seeing there is the design for up to 3 launch pads, catering from sounding rockets, as I mentioned, up to the launch of our ABL RS1 launch vehicle. They will likely have some radar tracking facilities there. They will have up to 3 integration buildings or hangars, so just areas where rockets can be assembled, rocket parts can be mated together, where the spacecraft and the satellites can be in a clean space, encapsulated into the necessary spacecraft or fairings of the rockets, and then everything can be ready to roll out to the pad for launch operations. So the Saxavord team are actively working that. We're working very closely with them. Our kind of relationship revolves around us kind of feeding in the requirements and the interfaces that we're going to need between the spaceport and the launch vehicles, volumes of commodities, those types of aspects. So the Saxavord team can go away, build, get operational, and be ready for us to turn up, plug and play all of our necessary infrastructure for a launch and get our launch away. Where Shetland are is, as you can see, the plans are fairly mature here from a design perspective, and the Shetland Island Council will be making a planning determination shortly, and then they will be moving full steam ahead with the build. It's also worth pointing out is what you can see on there is the full operating capability plans. So the Saxavord team are not necessarily focused on trying to get 3 pads, 3 buildings, and all of the infrastructure in place from day one. That will be built up over a period of time. So they will likely focus on and putting the minimum infrastructure in place to facilitate our Pathfinder launch, plus any other customer launches that they're lining up, and then they will build and develop that spaceport in that red boundary as you see it, over time getting towards a kind of 3-pad and multiple hangar scenario. So that covers a bit about our launch project and our spaceport interfaces. I'm now going to touch upon a little bit about our second project under our UK satellite launch program, and that's all to do with kind of payload and the satellite end of things. So what we are doing under our grant is developing a small launch orbital maneuvering vehicle, or an SLOMV, and that's currently being built by a company called Moog, who are based in Reading. And really what that is, you can see the image on the right hand side there with the blue solar array on the top, and effectively it offers a space tug capability. It has its own propulsion. What we can do is we can encapsulate 6 different 6U CubeSats. So when I talk about CubeSats, the ones that we're going to plug in here are say the size of a shoebox or the size of a microwave. We can slot 6 of those in around the periphery of that orbital maneuvering vehicle, and then we can put that OMV into the RS1 launch vehicle. Once the vehicle gets up into orbit, we can deploy the OMV, and then the OMV, using its own propulsion, can move and then deploy each of those 6 CubeSats into its own different orbit. And that really comes back to why use small launchers, and I touched upon about the difference between a kind of a ride share versus having a dedicated mission. And that's some of what we're trying to prove here in some of our offering, that we can help CubeSat and small satellite manufacturers get closer to their desired orbit through projects and activities such as this. So that's about the OMV. I've touched upon the 6U CubeSats. That's the maximum that the OMV in its current configuration can hold. Under the purpose of the grant, we are working with a company called Weatherstream, and they're building a 6U engineering test unit. You can see some kind of images of that in the middle of the screen. And really what they're trying to do is build kind of an environmental monitoring system with over time with a constellation of these 6U CubeSats that can build up weather data that they can then download and sell on to customers. And you can see there from the little kind of weather image in the middle, that was one of their CubeSats that they've previously launched has actually done a kind of a swathe of what was Typhoon Hagibis off the coast of Japan that was around a couple of years ago. So they're already got equipment up in space, satellites there gathering data, and what they're going to do is build upon that to build up to their constellation, and we're going to help to do some of that through this particular project. And beyond that one, we are in discussions with a number of other potential customers to utilize and fill the rest of the slots on that OMV and have that fully manifested for the launch. And as we progress those and get contracts in place, we'll make the necessary announcements in due course. So we're working on this OMV. We're working with customers to provide CubeSats for that first launch. But then also what we're doing under this particular project is looking at kind of testing and post-launch mission operations. So in the Harwell cluster that's based down in Oxford, the Satellite Applications Catapult has what's called a disk facility. And what we've done is we've leased a part of that facility, some clean room space. And what we'll be able to do is we'll be able to take that OMV once it's been built by Moog in Reading, take it in there to do some of its testing before we transport it up to the spaceport. And I've just put some imagery in there. You can see the kind of the outside of the building, some of the clean room space with some lifting equipment, and the missions operations center where we'll be able to kind of fly the OMV once it's deployed and in orbit. So again, trying to bring this back into what does it mean for the UK. We can already see through some of these images and what I've talked through that we're already seeing some growth in this particular area. So the OMV being built in Reading, we've got satellites being built and tested that we could fly on the on the OMV as a part of our Pathfinder launch being built and tested in the UK, and we've helped support the growth and the setup of this disk facility to provide clean room capabilities and kind of mission operations capabilities that can be used for future missions and future opportunities. So that's really what we're trying to do. So a heck of a lot of work, very difficult, but at the same time massively exciting. And myself and the team are really delighted to be a part of trying to deliver a pretty kind of cutting edge project in the UK. But before I close out and welcome any questions, I just wanted to touch a little bit upon regulations and safety, because it's really at the heart of everything that we do. So by virtue of launch, we have to be inherently safe, and we have to have safety built into everything that we do. I touched upon earlier that the CAA will act as the regulator, and all activities will have to be licensed. So the owner of the launch vehicle will have to have a license to operate that launch vehicle. The spaceport operators will have to have a license to conduct their operations. Whoever is operating the range will have to be licensed to do so, to help monitor, track, do all the telemetry, flight termination, clear maritime and air zones. And then also for any spacecraft or satellites that are being launched, they will also have to be licensed. So the regulator has got a key role in making sure that everything that we do is safe. And for those in the UK, you'll be very familiar, I'm sure, with the term ALARP, as low as reasonably practical. And that's what the risk mitigation approach that's been taken with regards to space flight activities. Things that we will have to consider, and it's definitely not exhaustive, and as you'd expect from a kind of unique perspective of this project of trying to develop a spaceport, deliver a launch capability with a regulatory regime that's relatively new. There will be inevitably more stuff that we uncover, but as we move forward, not only will we need those operations and those licensees licensed that I mentioned above, but we're going to have to think about on-site operations at the spaceport, the work being done with the launch vehicles, any processing of the satellites, any hazardous material, how is that handled and processed at the site. Some of the spacecraft, as I mentioned, the UMV has its own propellant, a green propellant that's being used. So there'll be propellant fueling operations required to get that propellant into the UMV at the spaceport. We'll need to make sure that that's safe, licensed, and appropriate. There's also considerations of the different termination systems that the launch vehicles may be using. I touched upon that one of the roles of the range will be to monitor airspace and maritime areas. We'll need to enforce any clear zones or exclusion zones when there's hazardous operations going on at the spaceport. And then once we get into space, we have our spacecraft into orbits and running missions, we need to think also to be responsible about end-of-life considerations and what's the potential for collision. And we have to consider kind of passivation and making sure that we take as much fuel and energy out of those vehicles as possible. So the risk of any further damage is mitigated to a LARP. And then really, what else? We've got some added complexities because, as I mentioned, we're using a US-based launch vehicle. So there are complexities, but nothing that we can't manage our way through. So we do need to ensure that not only does ABL put in place a launch or get in place a launch license from the Civil Aviation Authority to launch in the UK, that will also be required from the FAA. So there'll be a dual licensing request and need there to before any launch operations are done. We will need to adhere to the US-UK Technology Safeguard Agreement that I mentioned. So there will have to be strict controls and access within the spaceport to make sure that the right individuals with the right authorities can see the right information and hardware at the right time. We also need to think about international licensing agreements, primarily for either for airspace or deposition of materials. So for launching broadly due north of Shetland, we do go over Norwegian and Danish, as well as UK waters. So that's things that we will need to coordinate across our various partners and across the various governments and government departments. We will also need to engage Ofcom to make sure any use of the spectrum is appropriately licensed for all of the necessary communications that we need between the spaceports, the ranges, the vehicles, the spacecraft, and the likes. And then, notwithstanding, there'll be all the other kind of UK regulatory standards that we need to adhere to as the spaceport is built and as we transport equipment around. So that's all I was going to go through today. I hope you found that informative, and I'd be more than happy to spend the next 10, 15 minutes or so taking some of your questions.
Brilliant, thank you very much. Yeah, we've got a couple of questions in the chat, and yeah, anyone who's got some questions, just pop it in there and we'll sort of work through it. So we've got the first one from George. Is there a backup launcher should ABL run into issues?
Currently, when we don't have a backup launch provider, what we are focused on is making sure that ABL are successful and using ABL for our pathfinder. Should anything change that dynamic, then that's going to be a discussion that we will have to have with the UK Space Agency as the grant funder and ultimately our customer for this particular project.
Fantastic. We've got one from Bernard. Just many thanks for Grant. Do you see the regulatory process as a risk? And if so, is there a mitigation strategy?
So the regulatory process is a risk, but I think that's a risk because the regulations that are been put in place are new. So therefore, both industry and the regulator are learning what that means. Also, the CAA, they have obviously a rich heritage from regulatory perspective for all things airspace and aerospace, but so again, space flight is new to them. So it is a risk, but fundamentally we're committed to working together to make sure that we get activities licensed correctly and appropriately. So I think there's a responsibility of both parties here, where industry needs to make sure that they get their license applications in as early as possible into a decent standard, and then we'll engage and be proactive to support the regulator as they go through the process. So I do see it as a risk in terms of, is there a mitigation strategy? Not that I'm aware of at the moment. I think all we can do is, as I touched upon, try and get license applications in as early as we possibly can, and work where we can collaboratively with the CAA to minimise the approval timelines to the best of our ability. But ultimately, they are an independent regulator, so they will take as long as they need to approve any license applications.
Excellent, thank you very much. I've got another question from George. It is, were there no other US or non-US, Rocket Lab, for example, proven small launch vehicles which could have been used? Some might say selecting a launch provider who hasn't launched yet seems risky.
Yeah, good question. I think there are other providers out there that at the point of the grant award could have been considered, but I think fundamentally that there's got to be not just Lockheed. The rocket providers have also got to have an appetite to develop operations from the UK. So if we look at Rocket Lab, for example, they were setting things up. When the grant was awarded, they had done a couple of test launches out of Mahir in New Zealand, but over time they've focused on launch in New Zealand, and now are growing a second pad there to give them some more cadence, and they're also setting up facilities in the US. So I think what's become prevalent as we've went on this through this journey in this particular program is ultimately the rocket providers they'll have their own strategies, they'll have their own plans, and they'll have their own kind of key customers. So it depends on those aspects will drive a level of appetite from US providers or non-US providers on whether they want to launch from UK shores or be a part of the first UK shores. And what we're seeing is ABL are absolutely keen and absolutely on board to help support that. I fully agree with your comment. That selecting a launch provider who hasn't launched yet seems risky. Yes, it does introduce additional risk, but that's something we're just going to manage. And as I mentioned previously, we're trying to. They are focused on delivering a number of US launches before we deliver the UK launch as a part of that kind of risk mitigation strategy. So there will be proven technology launching from the UK when we do our Pathfinder launch.
So thank you very much. Got a question here from Kevin Brown. And I might append a bit of my question onto the end of this as well, actually. What is the maximum wind speed that the ABL launch vehicle can launch? And I was also going to ask, are there any sort of challenges associated to its, the relatively remote location of the launch site as well, on top of that question?
Okay, so I haven't got the specifics at hand, but what we have done is, because and definitely because we get this asked a lot. Well, Shetland's quite windy, isn't it? So that's not going to be optimum for launch. But we've got a huge amount of, and the Saxavord team have got a huge amount of weather data, and there's absolutely a huge amount of perfectly great launch condition opportunities and windows throughout the course of a year, which would facilitate several launches of an ABL RS1 as well as other customers. I mean, I know Saxavord's aspirations are they believe that with the data that they've got, and once they get up to speed, that they could, between a mixture of orbital and suborbital, launch up to kind of 50 a year. So there are naturally going to be periods where wind speeds and certainly maybe some of the winter months, the weather that we've had, we've obviously had a couple of storms in the UK over the last couple of weeks, so they definitely wouldn't be optimal launch conditions then, but there's enough windows across the year that makes launching from the UK still a commercially kind of advantageous opportunity to explore. That's why we're moving forward with that. Sorry, Dan, can you remind me of the second part to your question?
Yeah, so have you found there any challenges to logistical challenges in terms of the remote launch location of Shetland Island? So things like resupply, even sort of support from SMEs and things like that, being able to get out to that location and support the actual launch activities.
Okay, so logistically, yes, there are some challenges. Predominantly, we're going to have to get stuff from the mainland up to Unst. So we've got either options to ship that up there direct, or we ship to Lerwick as the main port, and then we use some kind of inter-island ferries. But ourselves and ABL have walked that path. We've been to the site. They don't see anything that scares us. I think also what we have to remember is Shetland has had a huge amount of industry. They've got a rich history of oil and gas being in town and facilitating the support of that industry. They're used to those big businesses coming in. So certainly from what we've seen, what we've experienced, and what we've researched and put in place, there's nothing that we can't overcome at this point in time. I think it's just making sure that we have a good comprehensive plan to be able to give ourselves the time to make sure that once we get into the UK, it's not a couple of hours down a motorway. We've got challenges because we do need to get them on ferries. But I think one of the strong points of ABL's solution is both their launch vehicle and all their ground systems is modular and containerized. So most of what's being sent over will just be standard kind of ISO shipping containers that we can put on a ferry and get up to Shetland and navigate around to the spaceport. So I think overall it's remote. But it's remote for a good reason. It's a great place to launch from. There's low kind of population density. God forbid anything went wrong. So for those kind of reasons, that's why we look for remoteness when we're launching and making sure that we're keeping our activities as much as we can away from the public and maximising public safety.
Brilliant, thank you very much. Yeah, no, I hadn't really thought about. Yeah, of course, there's a long history of oil, very similar in terms of like storage, safety, movement of heavy materials, kind of stuff. So like, yeah, no, that's makes perfect sense. We've got a couple more questions. Probably going to close it out after maybe one or two more, just so we sort of getting under the hour. So we've got a question from Ipching Fang, and would the large number of ComSats affect LEO, low Earth orbit safety for more CubeSats?
I mean, I guess I don't have an exact answer to that question, but I think what we've got to do is we've just got to we've got to be conscious of what we're putting up into space. We need to minimize debris. We need to do all of the necessary licensing and approvals in place to make sure we're not making things too congested or maximizing the potential for collisions. We have to provide space debris mitigation plans as a part of our license applications and examples like that. So we have to be responsible with what we're trying to put into space, and that's been another kind of clear message that we get from the UK government, that not only do we have to make as minimal impact on the environment on the ground, we equally have to be as responsible once we're in space. So clearly, yes, the more we put up there, as our customers ask us, the more congested there will be, and that's something we will just have to take cognizance of and be responsible in our planning and our deorbit operations.
Excellent, thanks. We've got, I think, two more questions in the chat, so we're probably going to close it out on those last two. So we've got a question from Brian Tucker. Do you see Itar being a risk?
I don't necessarily think Itar is a risk. It's just it's another policy or process or regulatory compliance that we have to adhere to. So clearly that's not going to be as prevalent for us if we weren't using a US launcher, because we wouldn't have technology there that would be subject to Itar controls. But because we do, that is just something we've got to manage. But that's kind of one of the kind of unique propositions and experience that Lockheed Martin brings to the table. We have a team in the UK helping to drive this forward, supported by myself, helping grow that kind of UK indigenous launch capability that the UK Space Agency is looking for. But equally, we have a team standing beside us that are based out in Denver and Colorado, who have a huge amount of experience in not only launch, but kind of international activities and operations, and therefore are kind of well versed in ITAR, trade compliance and export controlled factors. So as an added, I'd offer that it's an added complexity that not all mission integrators and launchers will have, but I don't see it as a blocker or a risk. It's just something that we'll have to navigate through and make sure that the operations and the activities and the tasks that we conduct are kind of approved ahead of time and managed accordingly.
Excellent, thank you very much. And then this is the last question I think we'll have, is another one from George. Can you / are you allowed to talk a little about the viability of SACs aboard, i.e. do you think there's enough of an addressable market given the launch latitude? If there was, or wouldn't we have seen more launch sites at that latitude already?
Okay, so yeah, I can't talk on behalf of Saxavord, but I can certainly give you Grant's opinion. So I absolutely think there's enough of an addressable market. I think that there's a huge amount of CubeSats being built in the UK and around the world. There is a massive demand there. What's lagging behind is there's not enough launch capacity to satisfy that demand. So I do think that there's the potential there, and as I mentioned, from Saxavord Spaceport's perspective, they are looking at both suborbital and orbital launch. So they're trying to kind of capture a larger segment of that potential launch market as well. I think in reference to the latitude, I guess what I would offer is, yeah, I mean, historically, if you look, a lot of the launchers that have gone off that we see on the news are massive launchers that are typically going from kind of equatorial spaceports that are looking to get into geo and beyond, and therefore those established spaceports, that we don't need to replicate Cape Canaveral because we already have one, as an example. But what we are seeing is more of a drive for these small launch class of vehicles getting into kind of low Earth orbit, and then using these kind of polar regions as ideal opportunities to be able to get into. So if we look at there's going to be the establishment of spaceports in the north of Scotland at that particular latitude. If we look, the US has a spaceport in Kodiak Island in Alaska, and then if we look on the other side of the globe, Rocket Lab has set up a spaceport and is building a second pad in Mahir in New Zealand. So we are starting to see more spaceports appear at these kind of latitudes, but I think that's been driven by this kind of CubeSat, small sat demand kind of outstripping launch supply, and then launch companies coming along offering these kind of small launch dedicated missions, something different than what's historically been offered before, and then exploring the ability to launch them from different latitudes and getting to different types of orbits. So you're right, we haven't seen many of them in the past, but I think we're just on the kind of precipice of that moving forward, and more kind of spaceports and more small launcher opportunities moving forward.
Excellent. Thank you very much. Okay, so that's the last question. Thank you for this, really comprehensive, really interesting presentation. I'm just going to hand you over to Ollie Westbrook-Neverton, who's going to do our vote of thanks and just close the meeting out. But thank you very much.
Good evening. Can you hear me okay?
Yep, loud and clear.
Cool, excellent. Good evening, Grant. Yeah, thank you very much for that really good talk. It's got a few minutes. I thought it was a really good initial explanation of how Lockheed Martin's structured, because it is quite complicated to outsiders, how you've got the corporation, space, LM UK Space. So I thought that was pretty good in the context of it. And also, because I initially had the same sort of question I think a lot of others had, which was, why don't you just go to Cape Canaveral? Why don't you just go to what Elon Musk can sort of give you? And your point, I think, is very valid in that you're offering, greater mission sort of customization, or more kind of flexibility, rather than having to sort of hitch a ride on someone else's bus. So I thought that was really good, and it, I think, also goes a bit away to explain the kind of viability of the launch site as well. If you're not sort of launching huge, massive rockets, you can probably do it somewhere more remote like Shetland, which has its advantages there as well. I also thought it was really good to touch upon the regulations, because I can imagine when you're setting up something new like this, I'm sure people are well aware of how regulatory this environment is, and all the kind of bits of red tape you've got to sort of get through before you can start getting to the engineering. So I thought that was really good to talk about as well. And that also obviously pulls in that other dimension of pulling US technology into the UK and all that kind of stuff. And also the supply base you've got set up and all the partners you've partnered with, I think, are quite interesting. How you're using people in the UK to sort of bolster this sort of technology from the US and achieve these sort of specific mission aims that you have. So no, I thought it was a very, very good informative lecture on Lockheed Martin's kind of drive in the UK, and I'm sure we will all be watching with great anticipation to see how this all goes over the next coming years, and I'm sure you'll be very, very busy doing so.
I'm sure we will be, yes.
Yeah, definitely. Yeah, interesting work Lockheed Martin Space are doing.
Perfect. Thank you. And yep, just thanks for everyone's attention and coming along this evening and your exciting questions. So yeah, exciting times ahead of what's happening in the UK. And yep, thank you all.
Yeah, excellent. All right, thank you everyone. Take care.
Thank you.
Thank you. Bye-bye.
Cheers. Bye-bye.